Now we have seen the standard errors of the qualitative data and quantitative data. That means here the standard error of single mean, difference of means, single proportion, difference of proportions, and also the confidence interval. Now let us see the problems on this. Now the variance of a population is 2. The size of the sample collected from population is 169. What is the standard error of mean here? Now, first you write down the given data here. Variance of a population means sigma square is equal to 2. Population variance is denoted by sigma square. But here we need the sigma value. So, sigma equal to square root of 2, that is 1.414 here. Then, the size of the sample collected from population is 169. That means n equal to the sample size is 169. So we know that here the standard error of mean is equal to sigma by root n. So 1.414 by root 169. So 1.414 by root 169 means 13. So it is 1.414 by 13 is equal to 0.11. So the standard error of mean is 0.11 here. Now, what is the effect on standard error if the sample size is taken from an infinite population or sample size is increased from 400 to 900? Now here when the sample size is increasing, what is the effect on the standard error of mean? They are asking here. Now we know that the standard error of mean is sigma by root n here. Now let us consider n1 is 400. And when it is increased to 900, then n2 is equal to 900. Now, when n1 is 400, then the standard error becomes sigma by square root of 400. This is sigma by square root of 400 means 20. That means the standard error when the sample size is 400 is sigma by 20. When coming to the sample size 900, then it becomes sigma by square root of 900, that is sigma by 30. Now they are asking here what is the effect when it is increased from 400 to 900. Now from this, what is sigma here? 30 into standard error. Okay. Now what is the standard error when n1 is 400? That is sigma by 20 here. So sigma by 20. Now substitute this sigma value in that. So 30 into standard error of 2 by 20. Now that means here when the sample size is increased from 400 to 900, it becomes 3 by 2 of the standard error of 2 here. So that is the effect here. Right? So when the sample size is 400, it is only sigma by 20. When the sample size is 900, it is sigma by 30. From this here, sigma equal to 30 into standard error of the sample size when it is 900. Then if you equate these two here, then it is SE1 becomes 3 by 2 into standard error of 2. Now let us see the same model here. What is the effect on standard error if a sample is taken from an infinite population of sample size 800 is decreased to 200? That means here n1 is 800 and n2 is 200. Then the standard error of x1 bar is sigma by root n. That means sigma by square root of 800. So square root of 800 means 20 root 2. So sigma by 20 into root 2. That is the standard error of 1, the sample size when it is 800. Then similarly, standard error of x2 bar is here sigma by root n2. Right? So that means sigma by square root of 200. That means here square root of 200 is 10 root 2. So that is SE2 here. Now they are asking what is the effect on standard error if the sample size is decreased from 800 to 200 here. Now from this here, what is sigma? Sigma is 20 root 2 into standard error of 1. When it is decreased from 800 to 200, then SE of 2 becomes here sigma by 10 root 2. Now what is sigma here? 20 root 2 into standard error of 1 by 10 root 2. Now root 2 get cancelled and here it is 2 times, right? So SE2 is equal to 2 into SE1, right? So when it is decreased from 800 to 200, it becomes SE2 becomes 2 into standard error of 1 when the sample size is 800 here. Assuming that sigma equal to 20, how large a sample be taken to assert with probability 0.95 that the sample mean will not differ from the true mean by more than 3 points. Now here they are asking you to find how large a random sample. Means here we have to find the sample size n here and the standard deviation is given as 20, right? So first you write down the given data, sigma equal to 20 and here the true mean will not differ from the, means here the sample mean will not differ from the true mean by more than 3 points, means that is the error. So error is here 3 and the confidence level is 0.95. That means Z alpha by 2 is 1.96. So to find the sample size when the mean is given, the formula is here n equal to Z alpha by 2 into sigma by E whole square. So that means 1.96 into sigma is here 20 by error is 3. So this whole square we have to do here. So 1.96 into 20 divided by 3 is 13.07. Now this square becomes 170.74 here. So that means the sample size is approximately 171. Now see one more problem regarding the sample size when the mean is given. So it is designed to estimate the mean number of hours of continuous use until a certain computer will first require repairs. It can be assumed that sigma equal to 48 hours, means the deviation is 48 hours. How large a sample be needed so that one will be able to assert with 90% confidence that the sample mean is off by at most 10 hours. So the sample mean is off by at most means here the limit of that error is given. So that means here error is 10 hours and sigma is given as here 48 hours, and how large a sample be needed so that one will be able to assert with 90% confidence. So Z alpha by 2 is 1.645. So these values you have to remember here. Then we know that the sample size is here Z alpha by 2 into sigma by E whole square. So that means 1.645 into sigma is 48 by the error is here 10. So this whole square is, right? So 1.645 into 48 by 10 is 7.90. Okay. Now this whole square we have to find. So 7.90 square is 62.35. So that means here the sample size is 62 because after decimal we have 3. So we have to round off to the same number. So the sample size is 62. What is the maximum error one can expect to make with probability 0.9 when using the mean of a random sample of size n equal to 64 to estimate the mean of population with sigma square equal to 2.56. Sigma square means here variance is given. Now this time here you have to find the error, right? So what is the maximum error? So here sigma square equal to 2.56 means sigma is square root of 2.56 is 1.6 I think, right? So and here the sample size is given as 64 and probability 0.9 means 90% confidence. So Z alpha by 2 is 1.645. So the formula for error is here Z alpha by 2 into sigma by root n. So that means 1.645 into sigma is 1.6 by root 64. So that is nothing but 1.645 into 1.6 by root 64 is 8 here. So this is here 1.6 by 8 is 0.2 into 1.645, that is 0.33. So the error is here 0.33. That is the error when the sample size is 64 and the standard deviation is 1.6. Now see one more problem on error of mean here. A random sample of size 100 has a standard deviation of 5. What can you say about the maximum error with 95% confidence? So that means here sample size is 100, has a standard deviation of 5, sigma is 5, and with 95% confidence they are asking. So that means Z alpha by 2 is 1.96. Then error is given by the formula Z alpha by 2 into sigma by root n. So 1.96 into 5 by square root of 100, that is nothing but 1.96 into 5 by 10 here. So it is 5 by 10 means 1 by 2. So 1.96 by 2 is here 0.98. So therefore the error is here 0.98. So in this way we have to find the maximum error and to estimate the sample